Welcome to EDU World Space.
This question asks us to draw the Lewis structure of each of the four-part series and indicate what type of ligand each molecule is going to be. So first we'll start with part A, which is an ethylamine. Now, Lewis structure is a representation of the valence shell electrons in a molecule. And so the way that we draw this, and the way that I like to draw this, is by starting just going left to right. You start with the CH3, so you're going to draw the C with the three H's around it and show those bonds. Then we move to the CH2, so again you're going to draw the C and the H, and then we're going to go to the NH2 and draw those. Now the nitrogen has a lone pair, so you're going to show those. What type of ligand it's going to be. We know what type of ligand a molecule is going to be based on the number of lone pairs or where your molecule is electron rich. And in this case, we only have one location, which is this nitrogen. And so this ligand is going to be monodentate. This next molecule, the trimethylphosphine, again, we're going to go left to right. So we're going to start with the phosphorus, so P, and then we have three CH3 molecules. So we're going to draw C, H, 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 draw those bonds, C, H, 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 and one more, carbon, hydrogen, 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 show those bonds, and then there's going to be one lone pair left on this phosphorus. And again, there's only one center that is electron rich, so this molecule is going to be monodentate. Moving on to parts C and D. For C, we have carbonate, so this is CO3 2-. So again, we're going to start left to right. So we're going to have a carbon with three oxygens coming off of it. And we're going to have one bonded with a double bond, and then two with single bonds. Now this one bonded with a double bond is going to have two lone pairs on it, and these two with single bonds are going to have three lone pairs on them, so that we have a total of 8 valence electrons, or 8 electrons around each atom. Now these oxygens with the three sets of electrons in the single bond to the carbon are going to each contribute a minus charge, so this whole molecule is going to be a 2-. Now this molecule has multiple sites where there are electron pairs, specifically at these oxygens that are have an extra pair of valence electrons. And so this molecule, depending on how it's configured, will be a planar molecule. It could be a monodentate ligand, or it could be a bidentate ligand. And lastly, we have ethane, or C2H6. So again, we're going to look at those two carbons. They're bound to each other, and then have 6 hydrogens around. Drawing those bonds, so all single bonds. And this molecule, ethane, has no electron-rich center, and therefore it is not likely to bind as a ligand.